I am now going to start working through the midterm review problems that are in my math lab. So once again, almost all the problems on the exam will be somewhere in these review problems. There are a lot of review problems, but so many of these are very quick answers. So although it seems like a lot of problems, I don't think it'll take you that long to work through them. So I'm going to flip back and forth between seeing what I'm doing here and actually seeing the questions. Hopefully I won't forget. Sometimes I forget to switch back and forth, so I apologize in advance if I'm talking and you're not seeing what I'm talking about. So for example, I'm going to try and share the screen, and I'm hoping in a minute you will see the so for example, here is the my math lab, the problems. So here's problem number 1. You can see actually there are 77 problems, which sounds like a lot, but a lot of these are very fast. So I'm going to actually work through these and explain them and then try and give the answers, and we'll see if it's correct. For instance, this first one looks like we're doing some limit problems. So number 1, use the graph of f to find the given limit. And if when necessary, state that the limit does not exist. So here we're looking at the limit of this function, f of x, capital F of x, and we're looking at it as x approaches 5. So in this case, they give us a graph. I'm going to enlarge this graph. So here's the graph we're looking at. So you can see the function is like the line. You can see it starts here. It's like a little sort of parabola. Then there's a gap, a jump, and then it continues up here. There's like a sharp corner, and it goes down here. Here's another gap. So this is the function. The x-axis represents the values of x. The y-axis represents the value of the function. So when you're trying to find the limit of a function when looking at a graph, in this case, I want to find the limit as x approaches 5. So here is x equals 5. So I go to my graph, and we're talking about this point right here. Now a limit means for the limit to exist, you have to approach the value of x from the left and from the right, and they both have to approach the same value of the function. So here's x equals 5. So we're looking at this point right here. As I approach it from the left, obviously the function is approaching the value of 6. If I look on my y-axis, looks like it's at 6. Now as I approach the graph from the left, it's also approaching 6. So that's the definition of a limit. When you approach the value of x from the left and the right, if it approaches the same value of the function, then you have a limit. So in this case, it's going to be 6. Let me remember the answer. So I go in here and I type in 6, and then I check my answer, and it's correct. All right. So actually, let's go to the next problem. Number 2 is another limit problem with a graph. So this time, we're looking for the limit of the function as x approaches -5. Here is the graph for this problem. So now we're looking at as x approaches -5. So here's -5. So once again, when you check the limit of a graph, you have to approach it from the left and from the right and see what they equal. So when I approach -5 from the left, you can see it goes to this point here, and it looks like it's 7. So from approaching from the left, the function approaches a value of 7. But when I approach it from the right, even though the function doesn't exist here, when I'm looking at a limit, I'm looking at what the function approaches. Well, it's pretty obvious this function is approaching a value of 5 as x approaches -5 from the right side. So when you approach it from the left, the function is 7. When you approach it from the right, the function is 5. Therefore, we do not have a limit, because you only have a limit when the function's the same when you approach it from the left and the right. The function has to be the same, no matter which direction you come from. Here, obviously, we are not approaching the same value. So for my answer, I would choose B, the limit does not exist, and that is correct. All right, another limit, looking at a function, determine the limit when looking at the graph of a function. Decide from the graph whether a limit exists. If a limit exists, find its value. So we're doing the same thing, really. We're looking at the limit of the function as x approaches 7. So once again, let me try and make this graph large. Now we're looking as x approaches 7. So as I approach 7 from the left, here is where x is 7. You notice when x is 7, the graph does not exist. That empty circle means there's like a break in the graph when x is 7. But you know what? When I'm looking at limits, I'm not looking at the exact value of x equals 7. Instead, I'm asking the question, what is the function approaching as x approaches 7? When I come at it from the left, I'm up here at x equals 5, x equals 6. I'm coming down, approaching x equals 7. What is the function approaching? The function is approaching y equals 1. Now, it never actually gets to y equals 1. But when I'm looking at limits, I'm not looking at that exact point. I'm looking at what happens as I approach the point. So from the left, as x approaches 7 from the left, the function approaches 1. Now I have to see what happens as x approaches 7 from the right. So here, x is approaching 7 from the right. What is the function approaching? It's approaching 1. Now the question is, when you approach from the left and the right, is the value of the function going to be the same? In this case, it is. The value of the function is going to be 1. So what's interesting is, for this graph, if someone says, what's the value of the function when x equals 7, you would say it doesn't exist because there's no point there. But if they say, and this is our actual question, what is the value, what is the limit? What is the limit of the function as x approaches 7? For you to have a limit, you don't have to have a point right there. You're just looking at, as you approach the value of x, what is the function approaching? So in our case, we've decided it's 1. So I put a 1 in here, and I check my answer, and that's correct. So that's an important principle of limits. Limits are not looking at what is the value of the function at that exact value of x. Limits are asking, What's the value of the function approaching as x approaches the value? All right, number 4. Here's a little bit of another detail. Use the graph of f shown on the right to find the given limit. When necessary, state the limit does not exist. Now here we have a difference. We're looking at the limit of the function f of x, but look at what x is approaching. As x approaches -3, but you've got this little plus sign up here in the top. What that little plus sign means is, if it's a plus, that means I'm only interested in what the limit is as you approach x from the right. Positive means, you know, on the XY graph, right? Positive direction is to the right, negative is to the left. So when they talk about, they ask for a limit, and they talk about x approaching -3 with the positive sign, that means the only thing they're looking at is what does the function approach when you come from the right side. Sometimes it's called the high side or the positive side. So that means I'm looking at -3, so -3, x is right here. I'm only looking as I approach the value of x equals -3. I'm looking at it as I approach it from the high side, and you can see the function is approaching the value of 5. Now, in the previous problems, when we were looking at a limit, we had to go from the left and the right. But by them putting this little plus sign here, they're saying all we care about is the limit as you approach it from the right side. We're not going to look at both sides for this problem, only from the right side. So as x approaches -3 from the right side, the function is 5. So I go here, I put in 5, and I check it, and that's correct. Now the next one. Here they have a function g on a graph. Now they're looking for the limit of g of x as x approaches 2, but you notice here you've got the little negative. So now we're going to look at the limit as we approach it from the left side. And we're not looking at approaching it from both sides. Because they put the little minus here, we're only going to approach it from the left side. So if I enlarge my graph, so as x approaches 2 from the left side, well, here's x equals 2. So from the left side, you can see it's increasing. And as I get closer and closer to x equal 2, what is my function approaching? Even though there's some goofy stuff going on at x equals 2, I'm not concerned with the actual value of the function when x is 2. When you're looking at a limit, you're looking at the value of the function as x approaches 2. And in this case, as it approaches 2 from the left-hand side. Looks like the function is approaching 5. So I go here, and I type in 5, and hopefully it's correct. All right. Another graph. However, this one's different now. All the problems up until now, you notice the limit has been x approaching a number, 2 or 5 or -2. For this one, we have the graph of a function, and they're saying what happens as x approaches infinity. So let's look at this graph. I hope you all realize that infinity is, you could think of infinity as the largest number you can possibly imagine. I mean, infinity means a huge, 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 huge number. So when you look at a graph, what that says is what's going on is basically you're trying to look at the function when x gets to be a really, really big number. Now, in my opinion, this isn't the best problem because you can see, look at my graph. When x is really big, it looks like my function, as x gets to be 8, 9, or 10, it looks like this function is starting to sort of go level, like it's going to flatten out. So I think what would happen is if we could even make this graph bigger and look at larger values of x, it looks to me like what's going to happen is the function is going to get closer and closer to this line but never cross it. I think that's what it's telling us. And what's the value of the function? What's the value of the y-axis at this? Looks like it's -1. So in other words, what's happening as x gets really large, and here they only give us a graph when x is 10. That's not very big. If they had made this graph and I could look at x equals 100, it would even be more obvious. But I can sort of tell what's going on is my graph is getting closer and closer to -1 as s gets bigger. So as x gets bigger, I'm going to say, I think the function is going to approach -1. All right, so that was a little different because in this case, we're looking at the limit as x approached infinity as opposed to just a normal number. Okay, number 7. Graph the given function and then find the specified limits. So you look here, they give you an actual function. They give you an equation. G of x equals x squared minus 8. And here, they actually give you 4 different graphs. So the first step is you have to figure out which of these graphs represents this function. This function is x squared minus 8. So first, you have to figure out which is the correct graph of the function. And then once you figure that out, they're going to ask you to figure out 2 different limits. So what this is going to happen is this is like a progression. You do one part at a time. So the first part is going to be for us to figure out which of these graphs represent this function. Now, a lot of times I do these sort of like trial and error. For instance, I'm going to ask myself, let's do something simple. Let's plug in x equals 0 and see what the function should be. That's pretty simple. If I plug in 0 for x, 0 squared is 0, 0 minus 8. Bottom line is, when x equals 0, the function is -8. I'm going to go look at these graphs now, and I'm going to see which one of these graphs, when x is 0, is the function -8. And I'll expand it. So here's A. It looks like when x is 0, so it looks like this graph so far is correct. It may not be the final answer, but at least for the point I'm looking at, it fits. But I need to look at the rest of the graphs. Let's look at B. What is the function when x is 0? Well, in this case, x is 0 is right here, and I actually have 2 different points, and neither one of them is -8. So I know right away this cannot be the graph of my function. So I know B is not a correct answer. Here's C. So once again, based upon the function, when x is 0, the function should be a -8. But for this graph, when x is 0, what's the function? The function is +8. Once again, this cannot be the graph of the function. And finally, if I go to D, once again, you have one of these where when x is 0, you actually have 2 values for the function. This cannot be the correct answer. So you know what? By simply looking at one point on this function, I was able to determine that A is the correct graph. Because once again, when x is 0, what's the function? The function is -8. And when I look at my equation here, when I plug in 0 for x, the function has to be -8. So I know that's the correct graph. So I choose it and I go and check it and it says I'm correct. Now it's going to go in and ask me to find my first limit. So now it's saying, okay, so now you know which of these graphs is correct. So go to that graph and determine the limit of the function as x approaches 1. So now I can expand this. So as x approaches 1, well, x equals 1 is right here. Now, once again, with a limit, you have to approach it from the left and the right and see if they approach the same value of the function. So as x approaches 1 from the left, it looks like it's right here, which looks like it's 7. And now as x approaches 1 from the right, it's also approaching a value of 7. From the left and the right, I'm approaching the same value of 7. So that means that this limit should be 7. Oops, I made a mistake. Oh, you know what it was? You probably know this. This has been -7, right? You guys are probably screaming at me as I kept saying 7. It's -7. All right, there we go. And now they have another limit question. Now they're saying, what's the limit as x approaches 2? So once again, let's go look at our graph. Let's go to find x equals 2. X equals 2 is right here. Now for a limit, I have to approach it from the left and the right. So from the left, looks like it's going to be, I think this is -1, 2, 3, 4, -4. If I approach it from the right, it's also -4. Hopefully and that's correct. All right, same problem. They give us the equation of a function. The first step is go figure out which graph is correct. And then they're going to ask us some limit questions. So let's do the same thing here. Now here, I'm going to plug in a value for x and then see what happens. However, on the problem I just did, I set x equal to 0 because that usually makes it pretty easy. But you know what? I'm not going to set x equal to 0 here. And why not? Because then I have a 0 in the denominator and I've got an undefined number. So instead, let's choose something like, how about x equals 1? So if I set x equal to 1, I have 1 over 1, 1 minus 3, which is -2. So now I know when x is 1, the function should be -2. Let me go look at my graphs and figure out which graph might be a possible correct answer. So once again, I'm looking at when x is 1, the function is -2. Let's look at A. When x is 1, the function is -2. But here, this looks like, to me, it's like -4. I'll check my math again, but I think it should be -2. I don't think that's quite right. Let's see what the other choices are. B, when x is 1, you can see here the function is actually like a small positive number. That doesn't look correct. How about C, when x is 1, the function here is -2. So it looks like C looks correct, although I have to check D, because it may also have the same point on there. I don't know. Let me go check D. When x is 1, the function looks like it's 4, so that's not correct. So once again, right away, by just choosing one number for x and plugging it in, I was able to determine that C should be the correct graph. Now, they're going to have me do a couple limit problems. The first one, they're looking at the limit as x approaches infinity. So once again, let's look at my graph. So x approaches infinity means you can imagine going as far to the right as possible. Here, x only goes to 8. infinity means way out here, but I can sort of see what the trend is. Once again, this graph sort of flattens out and it becomes almost parallel to this horizontal line. So you can see the function is getting very close to this value of, it looks like -3. So I would say when x gets very large, my function is getting closer and closer and closer to -3. So it looks like to me, the answer should be -3. And now they ask another one. What's the limit of the function as x approaches 0? So it's the same thing, except now I'm going to look at my graph. So now as x approaches 0. So once again, 0 is right here in the middle of the graph. But to determine a limit, you have to look at it as you approach it from the left and from the right. So look at, as x approaches 0 from the left, it goes down, and all of a sudden you can see how this function starts to go down really steep. And as what happens is, as x approaches 0, it looks like the function is going to be like -infinity maybe. It's going to get to be a very large negative number. Now what happens as x approaches 0 from the right? The same kind of thing happens, except here it's a positive number. So it's almost like the limit is positive infinity. But the bottom line is, and even from looking at this graph, you can tell when x is 0, remember for a limit, when you approach it from the left and the right, they have to approach the same value of the function. Well, obviously, there's not going to be a limit when x is 0, because when you approach it from the left, it's going to -infinity. When you approach it from the right, it's going to positive infinity. They're not even approaching the same value. Therefore, we need to say the limit does not exist. All right, another limit problem. All right, this one's a little more interesting now. Hopefully you're all pretty good at what's called piecewise functions. Piecewise functions mean that the function is not the same for the whole graph. In other words, look at this. F of x equals, and it's actually got two functions here. The top function is 4x plus 14, but look what this says. This function here applies for x less than -4. In other words, when x is less than -4, now what does less than -4 mean? It means, in a sense, like a bigger negative number, like -5, -10. Oh, that's true. Because remember, negative numbers, even though -5 sort of looks like a bigger number, but because it's negative, -5 is actually less than -4. -10 is less than -4. So this is saying, basically, this is saying from -infinity to -4, the function equals this. And you really think about this, this is going to be some kind of a sort of a line with a positive slope. It's going to be linear, the positive slope. But then, so that what we call this is just like the transition. The function changes when x is -4. Coming from the left, as we approach -4, this is my function. But once I pass -4, then my function is simply x, which is once again going to be in this case, a line with a slope of 1. So I have two lines here, both with a positive slope. So the first step is which one of these graphs, you can see each one of these graphs, if we look at it, they all, when x is -4, you can see there's a noticeable difference in the graphs. It's like two different lines. And this transition occurs when x is -4. Now the question is, which one of these is correct? Well, I would say one of the easiest things might be to do is to see what happens when x is 4. Now you notice the first function says when x is less than -4, and then here it's x greater than or equal to -4. So in terms of the actual graph, the second function actually contains the point x equals 4, but we can see what happens right at -4. In other words, for this first function, if I were to plug in -4 into here, it would be -16 plus 14. It's almost like as x is approaching -4, this function is going to approach -2. Let's see if that happens. Here, as x approaches -4 from the left, it looks like it's approaching -4. That's not correct. How about the next one? It needs to approach -2. As I approach -4 here, it looks like it's still -4. Let's look at C. As I approach -4 here, now here it is -2. Although the problem is, you notice these lines meet here, which is interesting. Let's go on to D. Now I'm looking at when x is -4, as I approach -4 from the left, this approaches -2, and it's got a empty circle here, so this could also be true. So now I've narrowed it down to C and D. Actually, C and D both look correct when I look at the first function. Let's look at the second function, and let's look at also at -4. Well, when you plug in -4 for x, it should be -4. So that means when x approaches -4 from the right, the function should be -4. So let's just look at C and D and see where it happens. So as x approaches -4 from the right, the function should be -4. But here, as I approach -4 from the right, the function's approaching -2. I don't think that's correct. Let's see if D looks correct. Now, as I approach -4 from the right, when I get close to -4, what is the function going to be? -4. And you notice here, it's an enclosed circle, which means you include that. And up here, it's an empty circle. So this is actually the graph of the function. So it's going to be D. So once again, the first step is to figure out which is the correct graph. Now they're going to probably ask us some limit questions. Now this is interesting. They're asking us the limit as x approaches -4. But now we've got the little negative up here, so it's only looking as we approach -4 from the left. We're not looking at both sides. We're just looking at as x approaches -4 from the left side. So here's my graph. So as x approaches -4 from the left side, what is the function approaching? -2. Even though it's an empty circle there, but it's approaching -2. So I should be able to put -2 here. And then the next problem says, what's the limit as x approaches -4? But I've got the little plus here. So now it's only asking me to look at the limit as x approaches -4 from the right side. So I go back to my graph, and I say, okay, as x approaches -4 from the right side, what's the function approaching? -4. Looks like the answer to this one is -4. Now here's what's interesting. This next question is saying, find the limit of f of x as x approaches -4. Now whenever we look for a limit, when x approaches a number, we have to look from the left and from the right. We know we've already done that. Up here, x is approaching -4 from the left, and the function was -2. As x approaches -4 from the right, the function is -4. What does that mean? We actually do not have a limit as x approaches -4, because as you approach it from the left and the right, they are not approaching the same value of the function. For there to be a limit, when you approach it from the left and the right, it has to be the same value of the function. So in this case, I'm going to say, actually, it does not exist. And that would be correct. All right, I'm going to stop here now because those first 9 problems were all looking at limits when you're given the graph of a function. So hopefully it's pretty clear now. It's not that hard once you understand what you're looking at to solve those kinds of problems. For number 10, now we're going to start looking at the limits when we're given a function or like an equation, an expression, not a graph. So let's go ahead. I'm going to stop now, and I'll start the next video here with problem 10.